Here are the exercises for lesson 4.2, which was an introduction to instantaneous rates of change. In this lesson, we primarily focus on difference quotients and simplifying them. So the exercises come from OpenStax Precalculus 2E, and they are listed here, but this star, I have edited the directions to better fit the material we covered. And so I will scroll forward to show you. We want to find the instantaneous rate of change at the given x value. And here I have x is 0, x is minus 1, and x is 5. So that is what we will work when we work these exercises. So as usual, I recommend you try these exercises first and then come back to the video where we will go over the full solutions. We begin, we have g of x is 3x squared minus 2. We want to find the average rate of change on the interval x to x plus h. This is the difference quotient here. So we want g of x plus h minus g of x, and then we divide by h. We practice these in our lesson, but now is the time to do some more exercises. The first thing I want to do is work with the numerator here, g of x plus h minus g of x, and simplify until I have this as h times something, and then I will go back into my difference quotient. So we have 3x plus h squared minus 2, that's g of x plus h, and then we subtract off g of x, which is 3x squared minus 2. And don't forget the parentheses here. This negative sign must distribute across the parentheses. Just like we were practicing in the video, we have to remember this is a product. X plus h times x plus h. So my first step, if we multiply all of this out, we get x squared. We have 2xh. And then we have h squared. Then we have minus 2. We have minus 3x squared and plus 2. Let's take one more, maybe two more steps. We have 3x squared. We have 6xh. We have 3h squared. And then, well, we just have minus 3x squared here, because here minus 2 and here plus 2 adds to 0. Now I really have one more step before I move up to the quotient part of this difference quotient. You see 3x squared minus 3x squared adds to 0. So in fact, everything I have left is h times something. I have 6xh. I have 3h squared. Now, let's go back here. This numerator, we have just calculated and simplified. This is h times 6x plus 3h. Now, we have divided by h. This is, the h over h is 1, and we have 6x plus 3h. This is our average rate of change on the interval x to x plus h. This is our difference quotient here. The next problem, we want the average rate of change from 1 to 1 plus h. So let's write what this is. This would be b of 1 plus h minus b of 1 divided by h. We began with the numerator, which is b of 1 plus h minus b of 1. Let's evaluate this function at 1 plus h. Here we have 1 over h plus 4. So here I have an h plus 4. And then subtract off b of 1, which is 1 over 4. Our strategy in this type of problem, as we practiced in our lesson video. And as we will practice again in this exercises, we must first get a common denominator. And it's just the product of these two denominators. So this one, I will multiply by h plus 4 over h plus 4. And the other term, you see, I just multiply by 4 over 4. This will allow me to add these two fractions. My common denominator here is 4 times h plus 4. And then in the numerator, I have a 4 minus, well, this is quantity, h plus 4. H plus 4. One more step. You see, we have 4 minus 4 once I distribute the negative, which is 0. So my numerator is just negative h. Now, this is beautiful because I have simplified b of 1 plus h minus b of 1 so that it is h times something. So now let's go back up here. b of 1 plus h minus b of 1 divided by h. We get minus 1 divided by 4 times h plus 4. 4 times h plus 4. This is our answer, and this is fantastic. This gives us the average rate of change of b of x from 1 to 1 plus h. Now, as a comment, if we were asked, and we will do some like this soon, but if we were asked for the instantaneous rate of change of b of x at x equals 1, we would take this and evaluate at h equals 0. You see, we would get negative 1 over 16. Okay, 15. We want an average rate of change here on the interval x to x plus h. Once again, this is a difference quotient, so this will be f of x plus h minus f of x divided by h. The numerator here, f of x plus h minus f of x. First thing, evaluate my function at x plus h. I have 2 x plus h squared minus 3 x plus h. Now subtract off, evaluate my function at x. We have parentheses and then 2x squared minus 3x. Now, as we have done in multiple problems, I need to simplify this until it's h times something. This is my goal. And this part you see is x plus h times x plus h. We have 2. We have x squared plus 2xh plus h squared. This is very similar to one that we did earlier in this video. And then we have, maybe this part I'll go ahead and multiply out. We have 3x minus 3h. We have minus 2x squared. We have plus 3x because I have distributed the minus sign. So far, this part, minus 3x and plus 3x adds to 0. But I will also have more adding to 0. Let me take a step first and distribute this 2. We have 2x squared. We have 4xh. And then we have 2h squared. Then I have minus 3h. I have minus 2x squared. So the 2x squared minus 2x squared adds to 0. What I am left with is h times something, and this is fantastic. This is what I want to get to here. So I am left with 4xh plus 2h squared minus 3h. Let's go back to our blue difference quotient, and we have just calculated and simplified the numerator, but as I write it here, I'm going to factor out the h from every term. So I have h times, I have 4x, I have 2h, and then minus 3. Now we just have h over h, which is 1, and then we're left with this, 4x plus 2h minus 3. This is our final answer. This is the average rate of change of f of x from x to x plus h. Another way to say that is the difference quotient, but simplified. The next few examples are where I change the directions. We want to find the instantaneous rate of change. at the given x value. The first one, we have this minus 2x plus 1. Find the instantaneous rate of change at x equals 0. Well, this would be, let's write it up here. We want f of 0 plus h minus f of 0 divided by h. And then you let h approach 0. Really, this is a limit calculation, but that type of thing you really study more in depth in Calculus 1. So what we are doing, which we did in the lesson, also these exercises, is we just simplify the difference quotient until it's defined at h equals 0, and then we can just evaluate at h equals 0. So f of 0 plus h is just f of h. Let's begin. F of h minus f of 0 is, well, we have minus 2h plus 1, and then subtract off, well, f of 0 is just 1. So we just get negative 2h. This one, we don't have too much algebra to simplify. F of h minus f of 0 is minus 2h. So let's jump into the difference quotient. F of h minus f of 0 over h. This is just negative 2. It's the slope of the line, as we would expect. As h approaches 0, well, there's no h in this expression. We just get negative 2. So this is our answer. Negative 2 is the instantaneous rate of change here in number 7. Next question, number 10. We want the instantaneous rate of change of this quadratic at x equals negative 1. So this we want f of minus 1 plus h minus f of minus 1. And then we divide by h. This is the average rate of change from minus 1 to minus 1 plus h. Then we let h approach 0. We begin with the numerator, f of minus 1 plus h minus f of negative 1. When I evaluate this quadratic at negative 1 plus h, I get 2 times minus 1 plus h squared plus 5, and then subtract off, evaluate at negative 1. Well, negative 1 squared is 1. And then we multiply by 2. Maybe I'll do it in 2 steps. So we have 2 plus 5, like this. It's 7. This part is minus 1 plus h times minus 1 plus h. So what do we get here? Well, when we multiply the first, minus 1 times minus 1 is positive 1. Inner and outer both negative h. So we get minus 2h. And then we have plus h squared. We have plus 5 minus 7 gives us negative 2. Almost there. Distribute the 2 in this first part. We have 2. We have minus 4h. We have plus 2h squared, and then there's this minus 2. So I have really one more step before I go into the quotient part of the difference quotient. I have 2 minus 2, which adds to 0. Now you see I have minus 4h. I have plus 2h squared. This is h times something. This is fantastic. This is what we want here. So now f of minus 1 plus h minus f of minus 1 divided by h. What is this? Well, the numerator is h times minus 4 plus 2h. Minus 4 plus 2h. Now, as h approaches 0, we get negative 4. So this is the instantaneous rate of change of f of x at x equals negative 1. Here's our last question in these exercises. We want the instantaneous rate of change of this function at x equals 5. Let's write what this is. We want f of 5 plus h minus f of 5 divided by h. And then we let h approach 0. So let's get started with the numerator, which is f of 5 plus h minus f of 5. We want to simplify this until it is h times something. Okay, f of 5 plus h, we have minus 1 divided by, well, what happens when you put 5 plus h in for x? The denominator is 5 plus h minus 2, which is 3 plus h. We have a 3 plus h here. Then subtract off, this is a negative 1 over 5 minus 2, which is 3. Okay, let's move things, because at this point, you should be able to say the strategy, common denominator. We have done this multiple times, which is wonderful for us. So this one we multiply by 3 plus h over 3 plus h. And this one we multiply by 3 over 3. My common denominator is the product, 3 times 3 plus h. Now, the first term, we have a negative 3, but the second, you see minus a minus is a plus. So we have plus 3 plus h. Now, this is where everything is wonderful for us. We have minus 3 plus 3 in the numerator, which adds to 0. And so we get h divided by 3 times 3 plus h. We have written the numerator of the difference quotient as h times something. Now we're ready to jump into this, which is f of 5 plus h minus f of 5 divided by h. We can copy and paste. Dividing by h puts an h in the denominator. So this is just 1 divided by 3 times 3 plus h. This gives us the average rate of change of this function from 5 to 5 plus h. But what we're interested in is the instantaneous rate of change. As h approaches 0, well, what do we get here? We have 1 over 3 times 3, which is a 1 over 9. So the instantaneous rate of change of f of x at x equals 5 is positive 1 over 9. Let me underline this, our final answer. So this is the end of our exercises video. Thank you, everyone.